Hi there, and welcome to 4.4. So, we are in Module 4, Topic 4.4. What we are now going to look at is applications of all the techniques that we have done so far. Now, not only in this module, but we are also going to look at overall techniques that we have learned so far, right from introduction to software testing. And also, you may want to bring in your perspective, what you have been doing back at your desk as a student of work integrated learning program that you could use. Those intuitive heuristics based, the oracle that you create for testing. And then also look at all the attributes that we need for that good test case, for completeness, for coverage. And we'll look at small, medium, large examples. In fact, even the complex one that we began with for this particular module. So let's drill deeper. We're calling it examples and case study and test techniques that you would have seen, classic ones, core ones that you have seen so far: equivalence class, boundary value analysis, domain partitioning, combinatorial, and decision table. Now, as we are looking at all of these techniques, one way to look at it is I'm going to apply that technique. In fact, we looked at it that way. All our examples were, take this problem, but we are going to solve it using a technique. Today, let's change gears and see how not only one technique, but a combination of techniques, that is something that will make it effective. So the combination of techniques is what we want to use now. Or look at it this way, that take up a problem, solve it using one technique, then another technique. So we take a problem, solve it using one technique, then another technique, and compare and contrast based on attributes. Either way is fine with us. However, looking at decision table and combinatorial would be our priority right now. And we'll look at all other techniques from that lens. So two examples. First one is a TV remote control software. This is software that is designed for the remote control, which has typical controls and options, using decision table design and develop test cases. That's what we want. While largely it would be commands, if you really see, on a typical television remote control, you would have on off for sure. In fact, it is one button that toggles. If I can visualize, there is a numeric pad to enter the channels. Then there is a volume up down button. Then we look at channel up down button. There are menu options. You look at menu, back, scroll, selection like the enter or the OK. Thus, you have got a lot of set of those controls which enable use cases. So, action of clicking 1 as a number in certain cases would probably set the volume to 1, whereas in certain cases it would mean a channel. Thus, there is now a context to what will happen when. There is also a sequence of what is going to happen when. If we look at that as our way of solving the problem, how does decision table help us in this case? When we switch on the television, the first thing that we could do is select a channel. So selecting a channel by sequence of keys is one use case. And there is also a timer involved that if I enter 1 and 2, which means 12, and if I pause for more than 2 or 3 seconds before I enter the third number, typically the television would interpret as I'm looking for channel 12, and the third number entered would be considered as if I'm trying to select the channel once more. So we have got this timing aspect as well. However, our problem will still be solved in the same manner. We will have conditions, actions, and rules. We'll have all the conditions here, the actions here. So I would rather have sequence of two numbers. Action should be select channel. I make it true, channel should get selected. This leads to an input which could be right from 00 to 99 combinations. So now you know that this rule 1 will work and have up to 100 test cases, 00 to 99. About television on or off. In this case, we would want the television to be on. Without the television on, there is no meaning to channel selection. So look at such scenarios and you would see that there is enough digital rigor for us to come up with a set of test cases using decision table as a technique. Let's quickly look at the second example that we have here. A web-based shopping cart checkout logic. So let me get this whole thing out of our way. So I'm going to erase all ink. A web-based shopping cart checkout logic. By number of items, by weight of items, and by value of items. So what do we have here? Three mechanisms. And now I would like us to put those 8 steps to use in this case. Again, we're going to use decision table, but we will use those 8 steps to understand what is it that we are looking at. So we are looking at numbers. So we'll look at numbers. So number is n. Number of items could be from 1 to say 20. I'm putting a notional limit right now. Weight of the items, right from 100 grams to 50 kg. And by value of items, we are looking at a minimum 100 rupee item to probably 10 lakh rupee item. If these are my steps, so these are the limits. I can have 5 number of items weighing 20 kg within this particular limit. But maybe I will not be able to buy a diamond which is just less than 100 grams but costs more than 10 lakhs. Of course, I should be having that diamond available on that particular website. How do you get to such a shopping cart with such kind of a logic? What is a technique that you would use? How would we go ahead and do that? Bring that solution up. Think of equivalence class. Would equivalence class be a good choice? Equivalence class would be a good choice. We have valid and invalid ranges. You can imagine that we have got valid and invalid ranges. These are the bounds, and I know there are out of bounds, valid, invalid ranges. So can decision table logic provide us over here with valid and invalid, number of items to be true, that is within the range and outside the range. So this becomes a rigorous program that you need to create from a testing perspective to come up with test cases. And is there one answer to this particular problem? Definitely not. If you look at the techniques, these could be applied in very different manner. Like with a decision table, I will always have combinatorial. Like the 2-key channel press, I get 100 combinations, 00 to 99. Thus, we are anyway applying multiple ways and logic of thinking with these, one of these or many of these or all of these put together, even from a thinking perspective. Even if we put in the logic of decision table based testing, we always have equivalence class in mind. Valid, invalid, true, false. And we can build multiple conditions around it, saying that n is the number of items, n within limits, w within limits, v within limits. And then true or false, all true, and then various numbers that are bought would actually have an action of a successful checkout logic. But you will definitely think of other techniques for such a web-based shopping cart checkout logic. Let's get to the next one. An insurance renewal premium. Premium calculation, it is done by age. Now let us consider that this is not only done for a life insurance, but we will look at a driver insurance. A driver insurance, typically between the age of 20 and 25 may be the highest. That is one of the examples that I have noticed, that they always provide between 18 to 25 highest insurance requirement by age. But between 25 to 35, the insurance premium goes a little down. But in both these bounds that we have, it is all based on number of claims. If number of claims are higher, we have a problem. Value of the claims also matters. So we clearly see a action-reaction, a cause and effect. Like we saw in our previous example, that there is a cause and effect in case of TV remote control, but web-based shopping cart was not a very convincing cause and effect. Thus, you would see insurance renewal premium calculation will definitely be a cause-effect relationship. It's by age, so there would be a limit for age between X to Y, number of claims, X1 to Y1, and value of claims, which is between R1 to R2. And then the combinations begin. The next example that we have over here, which is folder and file name generation for a digital camera. Various mechanisms used is, in this case, you would find that we could use a serial number. So at any given point in time, when we are using a serial number, we are having some serial number which is a 4-digit number. But we also match it up with the date. So we would like the date to come into play. And probably also time. Or a combination of these three. I may even have simple serial number based file name for a digital camera, or a date plus a serial number. Only date, would that be a good choice that I'm going to mark every file only with a date forces me to say that on a particular day I can only take one picture or the picture will be overwritten, because the uniqueness of a date is limited by 24 hours. It's going to remain the same. A combination of date and number will provide me with umpteen number of opportunities. But I cannot take more than 0000 to 9999 in a particular date, which may be still a good number. Or maybe I'm going to add one more digit to this and say that, okay, these many are possible. Now it becomes great. Further to this, I may even add the time. So imagine I have date, time, and serial number. Gives me another feature which allows me to sequentially put together the photographs that are taken in a particular day. In fact, allows me to say that this was done post lunch, or allows me to say that this was a morning time. If I only have the date and the number, I may have to look at the picture to figure out. But if I have a timestamp, a time of the day, then I don't have to worry about it. So you can see that one is this is feature rich and featureful. The other is it also provides me with a requirement specification analysis which can lead to test specifications. When I'm looking at date as an input, then comes in my format of the date. If my allowed formats are DD, MM, YY or MM, DD, YY, or I have DD, M, MM, YY, then I have these formats, various formats that come into play. Then each of these positions become a defined range. Thus, I start deriving all my ranges, all my analysis like a decision-making tree, and then can get to use of decision tables very clearly for both of these problems. This is a time to take a pause, not only pause, probably just stop the video here, spend a day in solving both these problems, both these sets of problems rather, we have 4 of them, these 2 problems and these 2 problems, by mechanism of equivalence class and decision table as well as use of combinatorial. I'm sure you will appreciate and also understand what these techniques mean. So this is a good time to pause over here. Let's move to one that we already saw, but I've put this together as a problem statement. This is what we discussed as a part of our combinatorial, which is again Firefox, Chrome, Safari, and my browser. I just created a fictitious Prashant's browser, my browser, which is not only supposed to go on various operating systems, on Windows, Linux, it's also going to go on mobile phone. So now I added another variant of mobile phone to it. And mobile phone variant is iOS, Windows Phone 8 and Android. So what's the strategy? I'm sure the strategy that we already discussed would be extended. And what kind of testing are we doing over here? We are doing IoT, interoperability testing. Browsers working on various platforms, browsers working on various systems, that is the personal computing and mobile computing platforms. That's how we look at them. So I'm not going to go deeper into this particular problem because we've already seen it, we've already discussed it, but we'll get to the next one, which I think is going to be like a case study. Case study which will require us to discuss things further and further on. So as a part of our 4.4, we will discuss some areas in this particular problem, and as a part of the self-study problem, a similar problem, we will extend it to what we really need to accomplish as a part of your self-study assignment. Right now, on this slide, spend some time and read this entire slide completely. So now that you have read this particular slide, you know what problem we are looking at. School attendance system. Each one of us have been to the school. You know that there is an attendance system. Typically, there is a teacher who would call out the name. There is no electronic marking. There is someone who calls out of the name from the register, and someone marks a P and A, P for present and A for absent, and then there are reports that are generated out of it. I'm sure there is a lot of schools that do this electronically. So ours is one school that we are going to do everything electronic. But now you would see the complications. There is a master database. From master database for that particular year, the student's current database is created on which there is presence or absence marked. Absence is marked along with a reason. Sick, there could be informed leave, or there could be a school program due to which a few students are supposed to be away. Maybe there is a school program like a technology or a quiz competition. Or there are competitions itself, which are sports competition. Someone is representing chess or gymnastics. So you would see that there is a tremendous consideration for building such an attendance system in the school. And this is for students, not for teachers. How would we go about strategizing for testing such a system? Would one technique be applicable, or do we need multiple techniques at once to solve the problem? The strategy is an open strategy. From a strategy and track perspective that you start, one track will never be better than the other till you reach to a certain point where you are able to compare by means of coverage, by means of completeness, by means of the granularity of the test cases. Mind you, only number of test cases should never be the metric. So every strategy would definitely be useful and can take you to closure. However, if you have a strategy that I'm going to use only equivalence class, that may not be a good strategy. A combination is what would definitely be required. Because I see that there would be names and other fields in the database which would typically require equivalence class partitioning. Whereas attendance, non-attendance is going to be a true or false. There are various combinations that the database needs to take. That would definitely be a combinatorial logic. Some of the menu items would probably be the decision table. But how much decision table, how much equivalence class, how much combinatorial? Now you can see you will need everything together. And if you remember those 8 steps that we looked at, if you recollect those 8 steps, I think those would be definitely useful in analyzing. Again, the pieces that we need to analyze are from a test specification perspective and solve such a problem. So these are some of the cases that I would bring it to you, which you have semi-solved. In fact, school attendance systems, we have not even attempted the solution. This is where you need to come in. You got to now start strategizing, looking at those strategies that you would use and take them to a closure. So in this particular topic and module, we had the 8 steps, the domain partitioning. We also applied those steps to other techniques. We looked at combinatorial and decision table based testing. and also a bunch of examples, everyday examples related to shopping cart on the web, a television remote control, insurance premium, school attendance system, browser problem. So these are day-to-day pieces, and in fact, I'm sure there are more than these examples that you see around you where you will be able to apply these techniques. One of the pieces that you would have already realized and recollect that, oh yes, I need something to do with state and state machine. That is coming in future modules. The other piece that also happens is lack of state and lack of timers. That in our thinking is not helping some of the scenarios, especially when we spoke about the traffic light. So those are the ones which are coming in the later modules. For now, with these techniques put together, a school attendance system like problem will require you to look at it holistically, not technique perspective. I hope now you have few techniques in your arsenal which you will be able to use and create complete, correct, and high quality test cases to solve your problems. Thank you.